Welcome everyone, I'm Jason Mays, Developer Relations Engineer for TensorFlow.js here at Google, and today I'll be telling you about how you can build the next generation of web apps with TensorFlow.js. So let's get started. Currently, over 68% of professional developers use JavaScript in production. And as you probably guessed, TensorFlow.js is a library for machine learning in JavaScript. And that means developers can run machine learning anywhere JavaScript can run, which is basically everywhere. This equates to zero install on billions of devices globally. You can just follow a link and it works on almost any device. In fact, here's all the environments we support: common web browsers, server-side via Node.js, mobile native via React Native or progressive web apps, desktop native via Electron, and even IoT devices like a Raspberry Pi via Node. And you can run existing models, retrain via transfer learning, or write your own models completely from scratch if you so desire, just like you might know how to do in Python, but in JavaScript or Node.js. So now TensorFlow.js is able to support the execution of other forms of TensorFlow models too, either directly or through our command line converter. We can digest and run TensorFlow Lite, MediaPipe, TensorFlow Hub, and TensorFlow Python models, which can help get more eyes on your research with an audience far larger than before, as the web is designed to have high shareability with just a single link. And with all this progress, we're actually growing pretty fast. We're currently the leading ML framework for JavaScript globally, so let's see some stats. In just 1 year, we've seen approximately 3 times the growth in our weekly downloads, now standing at 3.5 million, which has led to over 85 million CDN hits, and over 14,700 projects that depend on TensorFlow.js on GitHub alone. It's really exciting to see how many people are taking their first steps of machine learning in JavaScript and seeing the community and ecosystem grow so fast. Now, TensorFlow.js allows you to create pretty much anything you might dream up. So let's take a look at what people have been making. Here, InSpace use real-time toxicity filters in their web conferencing app. You can see that when a user types something bad, it's flagged before it's even sent to the server for processing, and it alerts the user they might want to reconsider what they're about to send, creating a more pleasant conversational experience on the platform. Include Health use our pose estimation models to enable physiotherapy at scale. With many folk unable to leave their homes or travel remotely these days, this technology allows for a remote diagnosis from the comfort of their own home, using off-the-shelf technology like a standard webcam that many people have access to. Or how about enhancing the capabilities of a typical fashion website? Here, I use a body segmentation model with some custom logic to estimate my body measurements, allowing the website to automatically select the correct size t-shirt at checkout. And this was made in under 2 days using our pre-made body segmentation model. You could even bring a character to life by combining multiple models. In this demo, we use pose estimation and face mesh detection running simultaneously. Now, traditionally, creating animation is a hard problem, but this pose animator tool by Partner Innovation here at Google allows you to draw any SVG character you like and then use your body to control it in real time, giving animators a motion capture solution to drive 2D character animation that anyone can use. Or taking this one step further, you can also control 3D characters too, like this great demo by Richard Yee from our community. This allows you to use your favorite character as your avatar for virtual meetings or live streams, enabling real-time motion capture to drive virtual avatars in the browser using a regular webcam. And yes, all of this is running in JavaScript. Looking at more creative applications, you can even turn your voice into a musical instrument using Google Magenta's tone transfer model that runs entirely in browser too. You can simply sing any song or tune that you wish and hear it being played by an instrument of your choice, allowing anyone the ability to now play an instrument with their voice and this generative model. Or what if we could make the world more accessible? Here, the Partner Innovation team at Google used TensorFlow.js to understand sign language gestures. This project is built using a combination of machine learning model outputs for face, hands, and body to account for the fact that sign language is communicated not only with the signer's hands, but also their facial expression, overall body position, and posture. Even better, this library can be used for any sort of gesture recognition, even beyond sign language, as it's generalizable to any human-computer interaction use case, which opens up possibilities for web-based creative experiences, fitness, health, and even human-computer interaction research. Now, everything you just saw was created using our pre-made off-the-shelf models that typically can be used in just a few lines of code. Since launch, we've released many pre-made models, and we're continually expanding our selection, which we'll hear more about shortly. We've got models across many categories, such as vision, body, text, and sound, for you to use in just a few lines of code. You can check out TensorFlow.js/models to see them all. And even better, you do not need a background in machine learning to use these, just a working knowledge of JavaScript is required. So let's take a look at some of these in action. First up, we've got object recognition. Here, we're able to run the popular Cocoa SSD model live in the browser to provide bounding boxes for 90 common objects the model has been trained on. This allows us not to only understand where in the image the object is located, but also how many exist, which is much more powerful than image recognition alone. Let's see this in action. So here you can see a web page where I've imported the code for our object detection model. I can click on any one of these images and in real time get classifications coming back to allow me to know what's in each image. But we can go one step further than this. We can enable our webcam, and now you can see me here talking to you today, and as I expand and contract my hands, you can see the bounding box change all in real time live in the browser. And the key thing to note here, of course, is that none of these images are being sent to the server for classification. All of this is happening locally on my machine in the web browser using JavaScript. Next, we have our face mesh model. This provides high-resolution face tracking that's just 3 megabytes in size and can recognize 468 points on the human face across multiple faces, all in real time. We're seeing a number of companies use this with existing web technologies, and a great example of this is by Modiface, who's part of a L'Oreal group that combined face mesh with WebGL shaders for augmented reality makeup try-on. On the image to the right, it should be noted that the lady is not wearing any lipstick. This is being augmented in real time in the browser, and the user can select different shades at will to see what's best for them, without even needing to go to the store or install an app. So let's see Face Mesh in action. And now you can see Face Mesh running live here in the web browser. On the left-hand side, you can see the machine learning in action, rendering this lovely effect on my face, all in real time. Now on the right-hand side, because JavaScript has such rich support for data visualization and 3D graphics, we can also run Three.js to render the point cloud in real time, and you can see I can even interact with it all here live as I speak to you. And notice when I'm talking, open and closing my mouth, everything updates in a nice way, and if I blink, you can see the granularity around the eyes as well. And this is running very smoothly in the web browser, but you'll notice that I'm actually running on my graphics card right now, WebGL, and that's getting around 24 frames per second. If I switch this to WebAssembly, you'll notice that this is now running faster, in fact, going to 26, 28, and we might even touch 30 if we're lucky. And that's because my CPU on my desktop computer is actually a much newer generation than my graphics card, which is several generations old. So here, this model runs better on the CPU than my graphics card. And that's completely your choice. At runtime, you can swap between the hardware at will. So if you want to run multiple models, you can run one on the CPU and one on the GPU to distribute the load accordingly. We also recently released 2 new pose estimation models in collaboration with research teams at Google. The first, MoveNet, is an ultra-fast and accurate model that tracks 17 key points optimized for diverse poses and actions and can run over 120 frames per second on an NVIDIA 1070 GPU client-side in the browser. The second, MediaPipe's Blaze Pose, gives us 33 key points and is also tailored for a diverse set of poses. This extra granularity, such as tracking both hands, could enable gesture-based applications that may be useful for certain projects. We also now have a 3D version of this model too. And both models have higher accuracy and performance than our original PoseNet implementation that some of you may have seen before. So we recommend you upgrade and try both of these out to see what works best for you and your intended use case. Next, we have body segmentation. Our BodyPix model enables segmentation of multiple human bodies, as you can see on the image on the right. Even better, it also brings back the pose, which you can see by the light blue lines inside of the bodies, and can distinguish 24 different body parts represented by the different colored pixels. And with a little bit of creativity, you can take a model like BodyPix and add some custom code to give yourself superpowers. So first up, invisibility. This is more advanced than simply replacing the background with a static image. For that, you wouldn't even need machine learning, of course. But notice here how when I go on the bed still deforms in the image on the right as I move around to give this really cool ghostly effect, or how the laptop screen still plays. This prototype uses body pics that we just saw to calculate where the body is not, so that I can eventually learn all of the background and keep updating the parts where it's safe to do so. Even better, this was made in just one day and runs entirely in the browser, meaning that people could try it out globally even without having any machine learning background. Simply click a link and the demo just works. And of course, no images are sent to the server for classification, leading to real-time results. Next, lasers. Another member of the community combined his love with WebGL shaders with TensorFlow.js to enable him to shoot lasers from his eyes and mouth. This uses the face mesh model we just previously saw to run in real time in the browser without any issues. Whilst this is more of a fun demo, you can imagine using this for a movie launch to amplify reach with a creative experience for fans or more. Or how about teleportation? By combining TensorFlow.js with other emerging web technologies such as WebRTC for real-time communication, or A-Frame for mixed reality in the browser, and 3JS for 3D, we can now even create a digital teleportation of ourselves anywhere in the world in real time. Here, I can segment my body from the bedroom, transmit just for segmentation to save bandwidth, and then recreate myself in the real-world environment with WebXR. Remember, all of this is running in the web browser, no app install is required, leading to a frictionless experience for the end user. Having tried this myself, it really feels more personal than a regular video call, and you can walk up to the person and hear the audio from the correct direction. In fact, maybe next time I'm presenting to you, I'll be able to do so in your own room just like this, as if I was standing right in front of you. And here we see an example from our community who use similar technologies to bring people from fashion magazines to life right before your eyes. Note that even with these fancy particle effects and machine learning running, it's running on a 3-year-old Android device and still performs great. Now, pre-made models like the ones you just saw are really easy to use. And here's an example for text search that uses the BERT Q&A model in the browser. Here you can find the answer to a question in any piece of text that you present to it. Examples like this are now possible with our BERT-based Q&A model in TensorFlow.js as illustrated in our collaboration with Creative Lab here at Google. You can see how we used it in a Chrome extension to use on any web page. Just ask the question and be scrolled to the answer that most likely fits the question asked. As no server calls are required, your privacy is completely preserved whilst browsing the web pages you love. Now you might be wondering how hard it would be to make something like this. Well, using a pre-made model in TensorFlow.js is really simple. In fact, the core code fits on a single slide, so let's walk through it. First, we import the TensorFlow.js library and the pre-made model we wish to use, in this case the Q&A model. Next, we can define the text we wish to search. This could be some text on the website, but here we're just going to use a simple string. We can then also define the question the user wants to ask, which of course could come from some input box in a real application. Now we load the question and answer model itself, and as this takes time to load, it's performed as an asynchronous operation. So we use the then keyword to wait for it to be ready, and once our model is available, our function will be called, which is passed the loaded model as a parameter. Finally, we can then call model.findAnswers, and we pass to this function the question we want to answer, along with the text we want to find the answer from. Again, this is an asynchronous operation, as it might take a few milliseconds to execute, but this promise will resolve to return an answers object, which we can then iterate through to find the most likely answer from the given passage of text. In this case, it would predict cats as the answer to the question we proposed, which is correct given the text we had to search. And that's all there is to it. It's pretty simple, so give it a try. Now, outside of pre-made models, you can of course write your own models from blank canvas if you're familiar with machine learning. Now, TensorFlow.js has two APIs you can work with. First is our high-level API known as the Layers API that's actually very similar to Keras. So if you've got experience with this in Python, you should feel very comfortable using this API. Next, we've got our low-level Ops API, which is more mathematical in nature and allows you to go lower level, allowing you to do things like linear algebra to bring pretty much anything you might want to life. So here we can see how it all comes together. At the top, we've got our pre-made models. These are built upon our Layers API, which itself sits upon the Ops API. Now, this then understands how to work within many different environments, such as the client side, which includes things like the web browser, for example. And each one of these environments can execute on a number of different backends. Now, by backend here, I do not mean server side. Backend in this context refers to the hardware on which it will be executed. So let's dive a little more into what backends actually are here. On the left, we've got the CPU, which is always available. Essentially, this is vanilla JavaScript, but it's the slowest form of execution. We've also got WebAssembly for faster CPU execution, and with support for SIMD and multithreading, our smaller models can run just as fast on CPU as our GPU implementation in the browser. We then have WebGL for GPUs, which supports 97.6 of devices out there, and yes, that means we can run on more than just NVIDIA GPUs. We can run on AMD and Intel too, so that means you can get great performance even on a MacBook without an NVIDIA graphics card. And looking towards the future, we're seeing new web standards being formed, namely WebNN and WebGPU, which we're also investigating to accelerate performance even further. And there's a similar story for server-side environments, which is provided by our Node.js support. Note here that our Node.js environment supports the same TF-CPU and TF-GPU bindings as Python. Both Python and Node are just wrappers around the C++ core, and this allows us to get the same or better performance than Python, as we too can leverage the CUDA and AVX acceleration, but also leverage the just-in-time compilation features of JavaScript. More on that later. Now, if you do prefer to use Python for your machine learning research, that is of course completely fine, and we support the ingestion of Keras and TensorFlow saved models directly within Node.js without any kind of conversion. And this is great as it allows you to directly integrate with web teams that are most likely going to be using Node.js as their preferred framework. Over 50% of users currently choose Node as their backend framework, according to the 2021 Stack Overflow Developer Survey. If you wish to execute your Python models in the browser, however, you can use our command line converter to convert the model.json format you need in the browser. As the browser-based implementation is a complete rewrite, so long as the ops or layers used in the Python model are supported, you should be able to convert without any issue to run on the client side. If not, you would need to change the model to not use that operation or contribute the missing op to the TensorFlow.js project. We are open source, of course. And this conversion step is only required if you wish to run a saved model in the web browser and is not required if you're trying to run it in Node.js on the server side. So what's the performance like? As you can see here, executing MobileNet v2 on both Python and Node with CUDA leads to less than 1 millisecond of difference for raw execution time. However, if you have a lot of pre- or post-processing, then Node.js can leverage the just-in-time compiler of JavaScript to see a significant boost in speed over Python. Here, we can see how Hugging Face, who are well known for their natural language processing models, converted their DistilBERT implementation to Node.js. This resulted in a 2 times performance boost over their Python equivalent. So if performance is top of mind for you, you might want to give Node.js a try, especially if your end goal is to expose via a web API for Inference, which is very well suited for the Node.js environment. So in summary, here are some benefits to running Node.js on the server side. First, you can use TensorFlow saved model format without conversion, which may in turn enable you to run larger models than you can do on the client side. And remember, with Node.js, you can leverage the full power of the server hardware just like Python does. And in some situations, it might not make sense to transfer a huge model to the client side. Maybe it's gigabytes in size, for example. Next, it also allows you to code in just one language. This is great for developers already using JavaScript. And even if you don't use JavaScript, currently 68% of developers do. And that enables code reuse across the stack, which for a small startup can be very beneficial as your existing JavaScript developers can deploy your machine learning models too for your business use case. And then finally, performance. As mentioned, our Node.js implementation talks to the same C++ bindings behind the scenes as Python does, so you get the same hardware CUDA acceleration for both CPU and GPU. However, due to the just-in-time compiler of JavaScript, if your model requires pre- or post-processing of data, you can get a performance boost in Node.js for free. And finally, let's talk about client-side superpowers that can only be achieved by running in the web browser should you convert your model to run there. Now first is privacy. Inference is performed on the client's machine, so no data is ever sent to a third-party server, maintaining data privacy for the user. This is particularly important for industries where it might be a requirement not to transfer the data to a third party, such as in the cloud. Not to mention there's growing concerns around privacy these days, and here you get that solved for free with TensorFlow.js. Next up is lower latency. As JavaScript has direct access to the device sensors like the microphone, camera, accelerometer, and much more, there's no round-trip time to the server and back again to analyze that data. In fact, latency to the server could be close to 100 milliseconds on a mobile connection. Assuming zero latency for processing and inference, the maximum FPS would cap out at around 10 frames per second if sending images one by one, which is less than ideal. With TensorFlow.js running on device, we can go much faster than that. Next up is cost. If there's no data being sent to the server, you've got less bandwidth and hardware server costs, as there's no server-side CPU, GPU, and RAM being hired for inference. That means you can just pay for the hosting of the website assets and model files, which is far cheaper than running a fully blown ML server. Next, interactivity. The web was designed for the display of content agnostic to device type. From day one, it supported graphical content and has evolved to handle even richer formats like WebXR and WebGL. As such, it has far more mature libraries for graphics and data visualization versus other languages, such as Free.js or D3.js, allowing you to code your ideas in hours instead of days or weeks. And then finally here, we've got the reach and scale benefits. Anyone can click on a web hyperlink and load a web page, and the machine learning will just work, with zero install required, and even better, you get more eyes on your work, allowing you to use your cutting-edge research in novel ways across industries. Now, on the subject of getting more eyes on your work, how can TensorFlow.js aid researchers? Well, what if you could get your research into the hands of more users? What we see here is the typical approach needed for server-side environments. First, you must install Linux, then CUDA, install TensorFlow, clone some GitHub repository, read the documentation, install the dependencies, and then maybe, if everything is on your side, it will work and you can run the example. On the web, anyone can visit a website and it just works. Even more engineers and creative folk can then start to explore the power of cutting-edge research for their ideas in minutes instead of hours, to see if it's even a good fit for their needs before committing more time and effort to go deeper. And many of these potential new users are aware of the new research coming out, but are unsure how to get started. Often, there's a programming language barrier or added friction for usage for a domain they're unfamiliar with. And offering a web-accessible model could encourage more users to try such a model in their respective industries, even if they're not ML experts themselves, which will in turn drive innovation and new ideas. And these ideas and use cases could lead to valuable feedback to researchers, as the industries the model would be exposed to would be far greater than ever before. This feedback and discovery of potential biases for real-world applications could then drive future improvements to the research model itself, thus enabling the creation of better models further down the line, leading to a positive feedback loop of new research model consumption, industrial innovation, and prototyping at scale, which in turn drives new research for edge cases discovered. This is in fact how we're working here at Google, which has led to improvements in our pose estimation models like our MoveNet model, for example, which after launch received feedback from companies in the healthcare industry who we then collaborated with to produce even higher quality models that now everyone can enjoy. And next, I'd like to highlight just a few examples of some of the tools and libraries that are coming out in JavaScript to make your lives even easier when working in JavaScript. So first up is Danfo.js, which is essentially a port of Pandas to the JavaScript community. And it provides a similar interface and API, so anyone who has used Pandas before can easily use Danfo.js too. And it's pretty fast. You can learn more about Danfo.js at danfo.jsdata.org. And on that note, How9 started a whole company around data science in JavaScript. They provide an easy-to-use web interface to understand and manipulate your data, which can then be used to train custom models in the browser or apply existing models to greater insights into your data. Maybe you can apply sentiment analysis to your comments in your dataset, which you can then use to visualize to see if that aids in finding an underlying pattern. This is all possible with this easy-to-use tool and is simple enough for anyone to use, opening up data science to a much wider range of companies and individuals. Furthermore, we've created benchmarking tools to help users understand how TensorFlow.js models perform on different devices. By choosing the custom model option, you can tell the tool where to load the model from, along with what backends and environments you want to benchmark with. We even support testing via browser stack to collect results from multiple devices remotely. The TensorFlow.js team have used this tool to help productionize many of the models you heard about today, and this tooling is now available for everyone to use over on our TensorFlow.js GitHub repository. And now to wrap up, I'll summarize some of the resources you can use to go further beyond this talk. For a more hands-on, step-by-step introduction, check out our code labs at codelabs.developers.google.com. You can simply search TensorFlow.js on this site to find a whole bunch of useful step-by-step guides. And if there's one slide you want to take a screenshot of, let it be this one. Here you can find our website for more details on the library, or check out even more of our pre-made models. You can view our open source code on GitHub and even make a contribution if you're up for the challenge. Check out our official TensorFlow forum to ask more technical questions, and remember to tag your post with TF.js so we can find it on that forum. We also have code examples you can fork in minutes over on glitch.com and codepen.io that provide boilerplate code for you to get started super fast. And of course, for inspiration, check out our short 10-minute interviews over on YouTube via our Made with TensorFlow.js series. For further recommended reading, I would suggest the following two books on the right. The first is by O'Reilly and is a good, easy-to-follow introduction to machine learning and JavaScript. The second is by Manning and was written by the folk on the TensorFlow team here at Google and goes a little bit deeper for those interested. So come join our fast-growing community. There's far too many examples out there every single week to fit into a single presentation, so check out the Made with TFJS hashtag on social, such as Twitter and LinkedIn, to see what people are making around the world. And if you make something using TensorFlow.js, be sure to use the hashtag too for a chance to be featured at future events. Now, we've also formed a special interest group to work on the key areas of research in collaboration with all of you. So do come join us to help define the future of the TensorFlow.js project. Currently, we've got research areas such as benchmarking and performance, platform support, new models and application areas, tooling and infrastructure, model security, and even server-side execution with TensorFlow.js Node. All of which are being actively worked on by people just like you, so do get involved or suggest a new area if there's enough interest. Or maybe you want to help spread the love for TensorFlow.js if you're feeling inspired. Well, we've also started a working group that meets monthly to help scale the outreach, education, and internationalization of content around TensorFlow.js through presentation opportunities, blogs, videos, and more. Get in touch with me directly if you'd like to champion TensorFlow.js in your country. So the only thing left now to say is, what will you make? My final example here comes from a member of our community in Tokyo, Japan. He's a dancer by day, but he's managed to use TensorFlow.js to create an amazing hip-hop video with some pretty cool visual effects using body segmentation. Now, the reason I end with this is that machine learning really now is for everyone, no matter what your background, and I hope TensorFlow.js can enable more people than ever before to start their journey with machine learning. Creatives, artists, musicians, no matter what your background, you can still use models in the ways the original model creator never even dreamt up, as you saw from just a few of the demos today. We look forward to seeing what you create, so please do use the Made with TFJS hashtag so we can find your work. And with that, thank you for listening. Feel free to connect with me to stay in touch. I'm Jason_Mays on Twitter, or Creative Tech on LinkedIn, or if you prefer, I've also got a Discord server. Here, I post all the latest finds around machine learning in JavaScript, innovation, web tech, and more. See you there.
All right, thanks, Jason, for the talk. I think Jason is on the online and answer questions in the chat.
Can you hear me?
Yes, please. Yeah.
I'm also
just a remind.
right now.
Sorry, just quickly remind. Anyone, if you have questions, please feel free to post in the chat. We will get it answered. And if you prefer to speak to us questions, you can raise your hand. We can unmute you to ask questions. Please go ahead.
I think I managed to answer most of the questions that came in during the talk. But yes, if you've got any more, feel free to put them in the chat right now. And if you're able to talk on the mic, then of course you can do that as well. Okay, one question came in. How friendly are all these tools for educating children? That's a really good question, actually. And we're seeing TensorFlow.js being used for education for machine learning across many different countries. There's actually a really cool website called teachablemachine.withgoogle.com. And it makes it really easy for people to understand how to train a machine learning system and also see what works and what doesn't work. And using that system, you can train a custom object detection model or speech detection model or even a pose detection model. And in a matter of minutes, literally under 2 minutes, you can just enable access to the web camera, point the camera at an object, collect some sample images, point at a different object, collect some sample images, and then click train model. And within 30 seconds, it will produce a model that can then distinguish between those two things. And our users range from the ages of 7 to 70. So it's a really diverse community of people we've got working on TensorFlow.js. And yeah, we'd love to see more people in education using it, as it's a really great way to visualize and understand the pros and cons of how machine learning can work and some of the pitfalls you might find. So using the Teachable Machine website, you can even understand what bias is, because if you have too many images of one thing, or you don't include enough variety of your images, then of course you can show how it can recognize one bottle but not the other one, and so on and so forth. And you can then visually show people how to fix that problem by adding more sample training data and then retraining the model, and so on and so forth. So do check out teachablemachine.withgoogle.com if you're interested in that. I see a question about Zoom, but I don't think it's about TensorFlow.js. And yes, I've seen sometimes Zoom is a bit laggy at times. But yeah, I'll leave that for the Zoom people to fix. I can't fix that myself, unfortunately. Is there a face, emotion, happy, sad, stress, etc.? So I assume you're asking about emotion detection in TensorFlow.js. As far as I'm aware, we have not made one ourselves as a team. However, there are models out there which are able to do such things, and there's no reason why those couldn't run in TensorFlow.js as well. So it's definitely possible. You might need to train one yourself or convert one that's already been made. I know that Google Cloud Vision API has the ability to detect some basic things like this as well, I believe. So whatever model they use exists, and of course that technically could be converted to run in the browser if you can find it somewhere online. And you can use our command line converter as described in the talk to convert it if it's already in a Python model format. Or maybe you can just use something like Teachable Machine to understand when someone's smiling versus not smiling and assign your own kind of attributes to that. So you could probably make something quite simple with Teachable Machine in a matter of minutes just to kind of test it on yourself. But of course, to get it to work on everyone, you need a much larger data set to make it work robustly. Cool. Any other questions? Feel free, don't be shy. I'm up here for a few more minutes. How do you typically choose the tools, TensorFlow versus PyTorch, etc.? So at the end of the day, you want to use what you're knowledgeable in and what you have the confidence in using. These are all libraries that you can use for machine learning. Obviously, I represent TensorFlow, so I'm more familiar with that. So I use TensorFlow myself. But depending what language you're using as well might sway your decision. So currently, the only way to do machine learning in JavaScript with a production level API like TensorFlow is TensorFlow.js. I don't believe there's a PyTorch.js or anything like that right now. So if you want to do it in the browser and get those benefits we just spoke about, like privacy and performance and cost savings, then TensorFlow.js is the way to go. But of course, if other things come out later, then of course it's up to you what you want to use, as you're free to choose whatever you wish. VS Code as dev. I'm not sure what the question is very exactly, but yes, you can use VS Code to code JavaScript and all that. And a fun fact, TensorFlow.js is actually used by VS Code to do the language detection. So fun fact, VS Code actually uses TensorFlow.js behind the scenes to detect what language you're writing in to do the syntax highlighting automatically. So TensorFlow.js really is everywhere. You might not realize it, but it is in a lot of places, and it works pretty well. Where can I find consultants for MediaPipe and TensorFlow.js? Great question. I'd advise that you post on the official TensorFlow forum. If you go on there and tag your post with TFJS, there's a special hashtag for the TensorFlow.js related posts. We'll be able to find your post and assign someone who is knowledgeable to answer your question. So if you do have a specific question, feel free to put that onto the official TensorFlow forum. And if it's something that you can't talk about publicly, then maybe try and connect with me on LinkedIn or something, and I can try and connect you privately with someone if that's more applicable. Yeah. What is the name for kids to learn website? So I'll just type this into the chat in case it was not heard. So teachablemachine.withgoogle.com is the website. If you go to that link that I've just put into the chat, you might need to copy it. I forgot to put the HTTPS at the beginning there. If you go there, you'll be able to use that very easily. Just click on Get Started, choose the image project, for example, choose the basic model just to try things out. And it should be quite self-explanatory. There's a little button to enable the webcam, make sure you allow access, and then you get some training samples for each class of object you want to recognize, hit train, and then you get a live preview appear on the right-hand side. If it works well and you like it, you can then export that data at the top right of the screen. There'll be an export button that allows you to download the TensorFlow.js model that was trained, which you can then host on your own website and use very easily. So do check that out if you're interested in that. And thanks, Carl, for adding the HTTPS there to make it a link. Perfect.